Chapter 6, Core Essential Minerals. This book focuses on highlighting the benefits and necessity of copper, iodine, boron, magnesium, and their supporting cofactors. Humanity has used these minerals since the dawn of time. These minerals and supplements are relatively cheap, simple, and safe. Sadly, because they are so cheap and because they actually improve your health, unlike pharmaceuticals, and they are essential to human life. Unfortunately, Big Pharma has done everything in its power to limit your access and awareness of them. And as you have seen, our Western healthcare system is not about healing people, but keeping the patients on highly profitable drugs and treatments that are sadly the third and fourth leading causes of death. We'll dive in more in the later section on the mineral crisis, but suffice it to say that most people have not had sufficient minerals and vitamins their whole life. Add to this the plethora of new stressors and toxins. It is impossible to get all the vitamins and minerals we need from food alone. So unless you have lived your entire life in the wild and have never exposed you to these toxins and stressors, you will most likely need to supplement to some degree. Vitamins and minerals are micronutrients the body requires to carry out a range of everyday functions. However, these micronutrients are not produced in our bodies and must be derived from either the food we eat or from supplements. Few minerals are more misunderstood and underappreciated than copper, iodine, boron, and magnesium. Although copper is the third most abundant essential trace mineral in the body after iron and zinc, most people consider it unimportant. Fear and misinformation have villainized it in the last few decades. I say this because, as a species, we have used it as a healing tool for over 10,000 years. Until the mainstream narrative changed in the 50s and 60s, copper was considered so safe that high doses were given to children as a purgative. While unbound copper does generate free radicals in vitro, the reality of copper being dangerous in the body is more imaginary than real. And as homeostatic mechanisms ensure copper is contained and transported safely in enzymes throughout the body, rather than being a risk, copper is in fact pivotal to our health. Copper is one of the most important essential minerals in the body, responsible for thousands of enzymes, and it is a core building block of every aspect of the body. In addition, bioavailable copper prevents oxidative stress, which it does by transforming oxygen into water or other usable metabolites in our body. Almost all of copper in our body is found in our organs, tissues, bones, or transport proteins, ceruloplasmin, and copper albumin, or in storage proteins, methylthioneins, or copper-containing enzymes. Most importantly, copper is the key building block of our mitochondria and essential to our production of energy, as well as the removal of reactive oxidative species that are the byproduct of our cellular respiration, the way we make energy. Without sufficient copper, we will get sick, we will become dysfunctional, and eventually die. Copper is essential for the proper functioning of these copper-dependent enzymes, including cytochrome C oxidase for energy production, superoxide dismutase antioxidant production, tyrosinase pigmentation, dopamine hydroxylase, that's for catecholamine production, lysyl oxidase, collagen and elastin formation, clotting factor 5 for blood clotting, and ceruloplasmin, antioxidant production, iron metabolism, and copper transport. Most features of copper deficiency can be explained by a failure of one or more of these copper-dependent enzymes. For instance, depigmentation can be explained by a tyrosinase deficiency. The defect of collagen and elastin causing abnormalities in the connective tissues and vascular system can be explained by a lysyl oxidase deficiency. Unfortunately, most research into copper deficiency has focused on acute, severe deficiencies. Acute deficiency is rare in humans and animals on typical varied diets. Marginal chronic deficiency, however, is much more common. The determination of copper needs and marginal deficiency is complicated due to the fact that while copper deficiency does not necessarily lower the level of copper-dependent enzymes, though it can, it does significantly reduce their activity. Even less discussed is what copper deficiency does to our metabolism. Without sufficient copper and magnesium, our cells fail to properly create ATP and bind it to magnesium for mag-ATP, which is the form our body utilizes the stored energy. On top of this, another significant reason we need to bring back the focus on copper is that through unquestionably bad science, iron has been pushed into our foods, bodies, and medicines in toxic amounts. And without adequate copper in the body, iron inevitably rises to toxic levels. Iron accumulates in the organs and tissues, and without drastic action, this iron toxicity will lead to metabolic dysfunction. I hypothesize that iron toxicity is the underlying cause of the majority of modern diseases. And only with sufficient copper can we maintain iron homeostasis, and only with a higher dose of copper can we remove the excess toxic amounts of iron from our tissues and organs. Part of the problem in how we have traditionally looked at and measured copper and iron levels is how we measure them in the body. Most tests look at blood serum levels, and as we know, with most of the minerals residing in tissues, organs, and bones, this is far from accurate. To accurately test our current levels of minerals, we would have to biopsy all the tissues, bones, and organs. As you can imagine, this is painfully expensive and only something you want to do if absolutely necessary. To further complicate things, ceruloplasmin levels in the blood elevate in response to disease and inflammation. It is one of the body's most powerful and first-line defenses. So elevated or low levels of ceruloplasmin are not solely correlated to the levels of copper in the body. We'll dive more into iron and copper in their respective chapters. For now, let us look at iodine. Iodine is also an essential element for life, and at atomic number Z53 is the heaviest element commonly needed by living organisms. It is required for the synthesis of growth-regulating thyroid hormones, thyroxine, and triiodothyronine, T4 and T3 respectively, named after their number of iodine atoms. A deficiency of iodine leads to decreased production of T3 and T4 and a concomitant enlargement of the thyroid issue in an attempt to obtain more iodine, causing the disease known as simple goiter. The thyroid gland cannot make enough thyroid hormones without a sufficient iodine supply. Therefore, the thyroid gland cannot optimally function in an iodine-deficient state. One of the consequences of an iodine-deficient state is goiter, swelling of the thyroid gland. Why is adequate hormone so important in the thyroid? Every single cell, muscle, and organ in the body depends on adequate thyroid hormone levels for optimal functioning. The thyroid hormone acts as the body's major metabolic regulator. In a low thyroid state, known as hypothyroidism, the thyroid gland releases inadequate amounts of thyroid hormone to meet the body's metabolic demands, reducing the metabolic rate. In a hyperthyroid state, the thyroid gland releases excess amounts of thyroid hormone, which results in an elevated metabolic rate. Iodine is also responsible for maintaining the normal architecture of the body's glands, including thyroid, ovaries, uterus, breasts, and prostate. When the glandular tissue cells have enough iodine, the tissues maintain a normal structure. When iodine is deficient, the architecture of the glandular tissue becomes disrupted and the tissue becomes cystic. Cysts are fluid-filled sacs that have a distinct border from surrounding normal tissue. Iodine is part of a class of elements known as halogens. Halogens are a family of elements that form similar salt-like compounds in combination with sodium and most metals. The halogens are bromine, chlorine, fluorine, iodine, and astatine. Problems arise with bromine, fluoride, chlorine, and perchlorate as these toxins have become commonplace in our environments, water, and food. In addition, they have toxic side effects and interfere with iodine functions in the body. It is worth noting that lowered amounts of iodine and increased toxins have created a silent second killer, iodine deficiency. Now let's look at boron. Boron is another misunderstood and sadly ignored mineral that has led to countless unnecessary suffering. There's a fascinating history around boron, and we'll share a link to a fascinating article on it if you want to read more, called Borax, Boron, Boric Acid, and Your Health. Boron has substantial beneficial effects across our bodies, from reproduction and development, calcium metabolism, bone formation, brain function, insulin and energy substrate metabolism, immunity, and the function of steroid hormones, including vitamin D and estrogen. We'll look more into that in subsequent chapters. Another essential piece is magnesium. It is one of the most abundant minerals utilized in the body. Historically, it was naturally present in many foods, but I will explain in the Minerals Crisis chapter why that is no longer the case. Magnesium is essential for every cell to function. Magnesium is required for thousands of enzymes. It is required for energy production, oxidative phosphorylation, and glycolysis. It contributes to the structural development of bone and is required for the synthesis of DNA, RNA, and the antioxidant glutathione. It lowers inflammation and is required for mental and emotional stability. Without diving in too much, you can see how much we depend on magnesium to thrive. We'll dive more into boron and magnesium in their respective chapters. For now, let's look at why the RDAs are failing us.